5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
This is a diagram of the engineering design process. The first step is to identify and define the issue presented by the challenge. Design a process that will separate a mixture of recyclable materials by their physical properties without manual sorting. The next step is to gather information. This requires research from the internet, speaking with experts, and may involve preliminary tests like measuring water quality parameters or stresses on a building element. Preliminary investigations to answer guiding questions. Physical versus chemical properties lab. What is the difference between a physical and a chemical property? Can anything about a material be changed without a chemical change occurring? How are materials that can't be recycled separated from recyclables? How can contaminants be removed without changing the recyclable materials? How could a material's physical characteristics like density be used to identify different materials? Can density be used to separate materials without touching them? In what ways are recyclable metals the same and different from each other? In what ways are recyclable plastics the same and different from each other? In what ways are recyclable paper products the same and different from each other? The next step is to identify alternatives to solve the issue or need. These could be processes or products. Next, students select a solution which best answers the issue or need. Design challenge. Brainstorm separation procedures. Then select the best solution. Then students implement the solution. Next, students evaluate the solution to determine its suitability to meet the need. Test procedures. Preliminary tests show some ideas work well. Some ideas show promise. And some just don't work at all. The cycle continues by refining the solutions to improve results. This may require revisiting the steps in the cycle. As this process unfolds, it is essential to communicate within the team and with all stakeholders, for example, teachers and clients. The refined procedures are more efficient, more effective, less messy. Good ideas are adopted by other groups, and recyclables are successfully sorted by their physical property. When complete, students communicate the solution to all stakeholders. Student teams present their results to the teacher, other students, and sometimes to community stakeholders. Student teams presenting their results.
To be successful, we will become aeronautical engineers, and we will engage into the engineering process. We will do research and analyze the problem. We will build our first prototypes and then test them. It is important that during this phase that if our rocket crashes or it fails to take off, we persist and keep trying. After testing, we will evaluate the rockets and determine what worked and what failed to work. Then we will redesign better rockets, build them, and compete against the observatory. Remember, the team who analyzes the information, makes the best choices, and doesn't give up will succeed. That is why you should listen to your older teachers.
That's one small step for man, one giant leap for mankind.